All right, let's jump right in. When you think about global power, what comes to mind? Probably things like economies, powerful armies, maybe big ideas. But what if I told you the real story is, well, it's literally under our feet? Today, we're digging deep to see how geology itself is drawing the new map of world power.
So, let's start with a really big question. I mean, where does all this stuff, our cities, the phone in your hand, our entire modern world, where does it actually come from?
Now, your first thought might be, well, it comes from great ideas, right? Human ingenuity. And yeah, you're not wrong, but that's not the whole story.
Okay, so maybe it's technology then. The engines, the code, the algorithms that run everything. We're getting closer, for sure, but that's still not the starting point.
Because here's the thing, it all starts in the ground. Fundamentally, everything we build, everything we use, comes from materials we pull out of the earth. The entire global system. Think about it. From the Industrial Revolution all the way to the digital age, it's all sitting on a foundation of geology.
So, to really get a handle on where we're heading, we first have to look back at the world we've already built. The 20th century, it basically ran on a handful of key resources. These became the absolute backbone of industry and, you guessed it, geopolitics.
And here are the big ones. You've got iron ore from places like Australia's Pilbara region, which gave us the steel to build our massive cities. Then there's coal from China and the US, providing that steady, reliable baseload power to keep the lights on all the time. Of course, there's petroleum, mostly from the Middle East, which became this huge geopolitical weapon, and then natural gas kind of came in as the bridge fuel to a greener future. The bottom line, if you controlled these resources, you pretty much controlled the industrial world.
But there's another resource, one we almost always take for granted, but it's just as critical. I'm talking about fresh water. And the huge issue with water is that it's spread out across the globe so unevenly.
And this visual really drives home just how scarce it is. Just look at this. A whopping 97.5% of all water on our planet is saltwater. That leaves this tiny sliver, just 2.5%, as freshwater. But wait, it gets crazier. Even that number is a bit misleading, because most of that fresh water is locked up in glaciers and ice caps, or deep underground.
So, when you boil it all down, what are we left with? It's something like 1.2%. That's it. Just over 1% of all fresh water on Earth is the stuff in our lakes and rivers that we can actually get to and use. That tiny, tiny fraction has to sustain, well, everyone and everything. It's kind of mind-blowing.
Okay, so that sets the stage. But today, a whole new resource map is being drawn, and it's being driven by a completely new set of materials. It's like a new gold rush, a global scramble for the critical minerals that are going to power our green energy future.
This map right here, this is basically the treasure map for the 21st century. You see lithium, which is absolutely vital for electric car batteries. It's mostly packed into South America's lithium triangle. Nickel, that's largely dominated by Indonesia. And then you have cobalt. Something like 70% of the entire world supply comes from one place, the Democratic Republic of Congo.
But here's where it gets really interesting. Just digging this stuff out of the ground is only half the battle. The real power, the new strategic choke point, and the global supply chain isn't in the mining, it's in the processing.
And this chart is the perfect example. Take cobalt. The DRC, as we said, mines around 70% of it. But look at this. China refines about 80% of it. And this isn't just the one-off. You see this same pattern with a lot of these critical minerals. It creates this massive bottleneck in the supply chain. What it really means is that global dependency has shifted. It's not just about who has the rocks, it's about who has the factories. And that gives whoever controls that refining step a ton of geopolitical leverage.
All right, let's talk about something you've probably heard thrown around: rare earth elements. Fun fact, they're not actually all that rare, but they are absolutely essential. They have these unique magnetic and optical properties that make them completely irreplaceable in high-tech gear. We're talking about the powerful magnets in wind turbines, electric cars, your smartphone, even in top-tier defense systems. And, surprise, surprise, geography tells the story yet again. China completely dominates this space. They control something like 60% of the mining, but a truly staggering 85 to 90% of the processing. What does that give them? A near monopoly on the absolute building blocks of modern tech. That is a very powerful lever they can pull if they ever need to.
So it's not just about minerals. The energy transition is also about harnessing natural forces, right? But here's the catch. Renewable energy isn't just everywhere. It's a resource too, and its availability is totally dictated by geography.
Take solar power, for instance. It needs a ton of sun and not a lot of clouds.
so it's perfect for subtropical deserts. Think about Chile's Atacama Desert. It gets more solar radiation than anywhere else on Earth. Wind power, on the other hand, is totally different. It needs consistent, powerful winds. That's why places like the North Sea in Europe or the Great Plains in the US are such natural wind energy hotspots. Your geography basically determines your potential.
And it doesn't stop there. For hydropower, you need what engineers call a gradient advantage, basically steep mountains and a lot of reliable water flow. That's why China, with the Tibetan Plateau, is such a hydropower giant. Geothermal is all about a tectonic advantage. You need to be right on the edge of tectonic plates, where the Earth's magma is close to the surface. That's why Iceland and Indonesia, sitting on the Ring of Fire, are perfect for it.
So where does this all lead? Well, the resource map is far from finished. It's constantly changing, especially as new tech unlocks resources we could never get to before. And that's creating some serious new wildcards in the global power game.
A perfect example of this? Unconventional hydrocarbons. Basically, this is oil and gas that's trapped in really tight rock, like shale. For decades, we knew it was there, but we just couldn't get it out. It was totally inaccessible. Then, along came a technology called hydraulic fracturing. You probably know it as fracking, and it changed absolutely everything.
This is the tech that fueled the shale revolution in the US, which rocketed America to become the world's top producer. But what's really fascinating here is the role of geology. See, countries like China actually have some of the largest reserves on paper, but their geography, it's mountainous, there's not a lot of water, makes it way harder and more expensive to get it out of the ground compared to the flat, wide-open plains of Texas. It just goes to show you, technology is incredibly powerful, but in the end, geology often gets the last word.
So when you step back and look at the big picture, from the cobalt in our phone batteries to the wind that turns our turbines, our future is being written by geography. And as this new resource map gets drawn, creating new dependencies and new strategic choke points, the old power structures are starting to shake. So the ultimate question for the 21st century isn't just what is going to power our future, it's who is going to control it.